Let's make a presentation titled Research of Creating Simulator and Control about Cold Tandem Rolling Mill. First of all, I will introduce the rolling of metal. Metal rolling refers to the action of thinning out using the difficulty and ductility of metal. There are things that rolling by heat as the construction method of rolling process performed mainly by human hand produces such as Japanese sword and gold leaf are cited. As shown here, there are two types: hot rolling, in which rolling is performed while the metal is hot, and cold rolling, in which rolling is performed at low temperature. Temperature is cold rolling at a temperature as low as 720 degrees Celsius for hot rolling from 900 to 1200 degrees. Hot rolling is characterized by the fact that the steel shell is so soft that the rolling rod is relatively small, and it is possible to process a great thickness cold meal carried out by applying a heavy load to the processing of thin steel plates. In addition, cold rolling enables higher machining accuracy than hot rolling. Here, we will again organize the features of hot rolling and cold rolling. Hot rolling has the feature that the steel sheet is so soft that it has excellent processability, and sheet thickness control is relatively easy. On the other hand, in cold rolling, since here is not applied, it has superior surface properties, and it is difficult to control the plate thickness because rolling a hard steel sheet, but it is said that precise machining is possible. In this way, hot rolling is suitable for machining that does not require plate thickness accuracy, and cold rolling has a surface that is excellent as finishing process. For this reason, in order to utilize the advantages of each cold rolling will be done after hot rolling. Next, I will explain the cold tandem rolling mill, including this title. First of all, regarding cold, it was described above. Tandem rolling mill is one in which the steel plate passes through a plurality of rolling stands arranged in series in order to perform rolling in stages. Main application of steel sheets produced by cold rolling are various kinds, such as automobile body, aluminum cans, building materials, electric appliances. Next, we will explain model-based development. In model-based development, data is acquired by simulation using the created model. It is a method of doing development based on that data. In the case of development using actual machine experiments, it may be useful if it is a compact system. It is particularly difficult from the viewpoint of time, cost, and experimental environment to prepare a plurality of large rolling mills like this one for the experiment. Since it is not easy to upgrade the system, it is useful to acquire a model and develop by simulation. Therefore, in this study, we made a model of a cold tandem rolling mill. There are linear approximation models and non-linear models in the model, while the linear approximation approximation model has the advantage of high calculation speed. It is reliable to changes in dynamics such as disturbance and has the limitation of high precision control. In the steel rolling model currently in MATLAB and Simulink, a linear approximation model is mainstream. Non-linear model has been developed. For this reason, we developed a non-linear model using MATLAB Simulink this time. From here, we will enter into the content of the development model. First of all, as a flow of calculation, we go into the simulation after calculation called setting calculation. In the setting calculation, we calculate the parameters of 5 stands in the equilibrium state. It is trained to implement the parameters obtained by the setting calculation in the simulator and perform the simulation. In setting calculation, roll gap and roll speed in equilibrium state are derived. The roll gap is the distance between rolls when the rolling stand is not rolling the steel sheet. Roll speed refers to the speed of rotation of the roll. I will omit detailed explanation of mathematical formulas, but these two are requested by setting calculation. Next, we created a simulator using Simulink. The one shown in number 1 is the system from the first stand to the fifth stand, and the internal structure of each stand is shown in the second figure. In each subsystems that calculate each parameter are incorporated as indicated by number 3 and by performing the calculations. Finally, you can get the thickness and the fifth stand artifact. Here, simulation using a simulator was performed simply. We set PI control against roll gap and set problem to compare change of plate thickness due to disturbance with simulator without control roll. The first stand entrance plate thickness adds to the plate thickness as disturbance while changing the noise with weights of 0.01 to 0.08 millimeter with respect to 1.92 millimeter while changing it every 0.1 seconds. For the fifth stand outlet plate thickness, set the target value to 0.8 millimeter. Regarding the gain of PI control, P gain is 50 and I gain is 100 for all stands. Here is the execution result. The line indicated with orange is one with control roll. The line indicated with blue has PI control roll. Through those thickness of the orange line which does not have the control roll indicated at the final stand exit, the thickness with the PI control roll is stable and roughly 0.8 millimeter. I will enter the summary. In conclusion, setting calculation was carried out and parameters were obtained under given conditions. In addition, we developed a simulator and succeeded in implementing an operating the numerical values obtained by setting calculation. As for future tasks, it is now possible to obtain parameters that seems to be ideal at present, but we have not verified the validity of parameters obtained by setting calculation. We believe that it is necessary to verify whether reliable literature values for actual setting data are really correct by obtaining actual data. Also, since the operation of the simulator is not yet complete, we need to proceed further verification. The presentation is ended with the above. Thank you for listening.